8, where we're going to factor polynomials completely now. So let's talk about definitions first to understand what that means. So first of all, when we factor by grouping, what's going to happen is that we're going to have 4 terms. So factoring a polynomial with 4 terms is what we're going to do is we're going to factor them by grouping them. We're going to factor a common monomial from a pair of terms and then look for a common binomial. Pretty wordy, right? We're going to do some examples to make sure that you understand that. The other thing I want to talk about is what does factor completely mean? When we're factoring a polynomial, we want to factor it until it is written as a product of unfactorable polynomials with integer coefficients. So that means you factor it till it can't be factored anymore, and an integer coefficient, that's the number in front, right? What is an integer? It's a positive or negative whole number. So let's talk about factoring by grouping. So here what we have is we're working our way up to having 4 different terms. Down here you can see we have 4 different terms. This is the step before we get to those down there. They've started it for us, and what happens is we have a common binomial term. Remember? Common binomial term. That's right here, x plus 2 and x plus 2. So 3x has to get multiplied by that, and so does negative 2. So another way to write that would be a product of binomials, x plus 2 times 3x minus 2. If I had started with this and I told you to FOIL it out, what would you have done? You would have done 3x times each term in there, and you would have done negative 2 times each term in there. So that's another way to write this. So our goal when we get down to 4 terms is we want to factor out the groups so we have a common pair inside. This one looks like we have a common pair inside, y minus 4, but this is 4 minus y. So that one's backwards. But if I take out a negative 1, if I factor out a negative 1, we end up flipping this around, and that will be the negative number, which is what it's supposed to be, and this would be the positive number. So the solution down here says the binomials, y minus 4 and 4 minus y, are opposites. So we're going to factor negative 1 from the 4 minus y to get a common binomial factor. So what I'm going to do is I'm going to take a negative 1 out. So now this becomes a negative 1 times 3, or negative 3, and this becomes a negative 4 and a positive y. So just to rewrite, it's minus 3 or plus negative 3, and then it's y minus 4. Now I have that common term, so I write the common term, and then I rewrite what's left over in the other parentheses. So that was the middle step building up to example 2. In example 2, I have 4 terms. I need to factor them by grouping. The first thing we want to do is we want to have them in descending order. I have them in descending order. So I am going to group the first 2 together and the last 2 together, and they leave me a space just to rewrite that. Now you're going to take out the greatest common factor in each of those binomials. So y squared is the greatest common factor there, and what am I left with? Y plus 7. Over here, the greatest common factor is 2, and what am I left with? Y plus 7. So I did it. I have a common binomial. It's y plus 7, and that gets multiplied by the other 2 terms, y squared plus 2. Okay? Now, you don't just have to have one variable. You can have multiple variables. So let's take a look here. Hopefully it's going to work. I'm not quite in descending order right now because of the craziness of 2 variables, so we're going to group it like this and see what happens. So we have y squared plus 2y and yx plus 2x. What's common here? A y, and I'm left with y plus 2. What's common over here? An x, and I'm left with y plus 2. I have my common term, which is y plus 2, and what's left over? Y plus x. If you FOIL this out, you will get this original equation. Okay, so let's look at example 3. In example 3, if I group right now, am I going to be able to take anything out of this guy? No. I can take something out of this, so you can tell that what's going to be left in parentheses isn't going to have a common factor. So I'm going to have to do some rearranging. So it says the terms x cubed and negative 2 have no common factor. So we need to use a property to rearrange the terms. What property can I move things around? Commutative property of addition. Yep. Commutative property to rearrange the terms so you can group them. So I'm going to put them in descending order. That's why we practiced that earlier this unit. Okay, so now I have them in descending order. Now I'm going to group them. They left me a line to rewrite that. I'm too lazy to do that. I'm just going to group them like that, and I'm going to factor out the common term right now. So what's common in the first one? An x squared, and I'm left with x minus 4. Plus sign. What's common here? A 3, and I'm left with x minus 4. Bingo, there's my common term, which is x minus 4, and what's left over? X squared plus 3. All right, so we have a checkpoint right now. What you need to do, some of them may have a negative you have to factor out, but go ahead and pause and then come back and see how you did. All right, let's see how you did. So in this one, we already have our common terms. They set it up for us, which is z minus 6, and the leftovers go in the other bracket for 5z plus 4. In this one, here's where you had to take out the negative 1 first. So taking it out brings the negative out in front of the 7, and y minus 1 is left. Now I have my common terms. So it's y minus 1 and 2y minus 7. All right, in the next guy, you need to group them. And I have a common factor of x squared in this first grouping, and I'm left with x minus 4. Took out the 5 here, left with x minus 4. There's my magic number. X squared plus 5 is left. The last one you had to reorder because they were not in descending order. So I reordered, and then I put my brackets around the first 2 and the last 2. N squared came out, and 6 came out. The n plus 8 is left, n squared plus 6 is the other binomial term. All right, see Mrs. Wyman if you're having trouble with that. Otherwise, carry on here to the guidelines for factoring polynomials completely. We haven't gotten to the completely part, and that's what we're going to do now. So step 1, when we're factoring polynomials completely, you should factor out the greatest common monomial factor. We've been doing that. Then you look for a difference of squares or a perfect square trinomial. Those are the shortcuts. That is 9.7. Those are the shortcuts. So you have to have those shortcuts memorized to be able to recognize now that I can take a shortcut. So that is always step 2. Step 1, take out the GCF. Step 2, look for a magic pattern. Step 3, factor a trinomial of the form ax squared plus bx plus c into a product of binomial factors. So that is 9.6. No, not 9.5, sorry. We haven't done 9.6. That's 9.5. And then factor a polynomial with 4 terms. That's the one you just learned, grouping. Now I actually, if we have 4 terms, I kind of bump this guy up to number 2 because I can recognize its grouping right away, and that's what we'll probably do. So let's look at some examples. We have 3 different things here. The first one is x squared plus 3x minus 7. So take a look at that guy. Can I take out a greatest common factor? That's step 1. Nope, no greatest common factor. So then I need to say, hey, is this a shortcut from 9.7? Nope, not a shortcut from 9.7. That's not a perfect square trinomial. So then I have to say what multiplies to negative 1 and what adds to 3, back to 9.5. What multiplies to negative 1 adds to 3? Well, 1 times negative 1 is 1, and 1 plus negative 1 is not 3. So guess what? There are no factors of negative 1 that have a sum of 3. So this polynomial cannot be factored. Nice, they gave us that one right off the bat, wasn't it? Okay, that one can't be factored. Let's look at B. In B, do you see a greatest common factor that can come out? Yes, you should notice that it's 3r. A 3r can come out. So then we are left with, in our parentheses, r squared plus negative 7r or minus 7r plus 10. Now, this is where we're not done. I have a trinomial. So I take it and I say, is it a perfect square trinomial? Well, no, because that's not a perfect square. So then I have to use my 9-5 tricks. What multiplies to 10 and adds to -7? Well, what's 2 times 5? 2 times 5 is 10, a positive 10, but I need a -7 there, so it's a negative times a negative is a positive, and then -2 plus -5, yes, that's -7. So those are my two factors. So my factors are, so 3r, it just stays out there, and then I have r minus 2 and r minus 5. That is factored completely, so you're going to have to use a couple different tricks on each one of these to get them to factor completely. For example, look at C. C is pretty interesting. What do you do first? You look for a greatest common factor. I have one. It's d squared. So the d squared comes out, and what's left? 9d squared minus 4. Now that can also be factored. The d squared comes out, but this is 9, 7. This is a shortcut. It is a sum and difference pattern. Perfect square, minus sign. Okay? So what times itself is 9d squared? 3d and 3d. What times itself is 4? 2 and 2, and this is sum and difference pattern. One's plus and one's minus. That's how the middle two terms cancel out. If you're not recognizing those shortcuts from 9-7, you're going to need to go back and do some more practice on 9-7 or watch the videos again. Before we do example 5, I want you to go over here and I want you to do number 5 and 6 checkpoint. Pause the video and try them out. Okay, so checking these, the greatest common factor, first of all, is a -2x. You're left with x squared minus 3x minus 54. It's not a perfect square trinomial, so I need to do my sum and difference here of what multiplies, not sum and difference, product and sum, what multiplies to -4 and adds to -3, and that's -9 and 6. So it's -2x times the quantity of x minus 9 times the quantity of x plus 6. And remember, these can be in either order. The GCF always goes out in front. The next guy, what's the common factor? It's a 3y squared, and when you take it out, you're left with the sum and difference pattern. Perfect square, minus sign. So that ends up being 3y squared times the quantity of 2y minus 5 times the quantity of 2y plus 5. Now we haven't done one yet, but you could be left with a perfect square trinomial in there as well, and then you would have to use your shortcut pattern. Okay, so let's go back now to example 5. In example 5, we are solving now, so we're finding out what x could be. The first issue we have is that this minus 30x is on the wrong side, so we're going to add 30x to both sides to get it to the other side. Then we've got a problem because we have a greatest common factor that we need to get out of there, and that greatest common factor is 5x. So I am left with x squared minus 5x plus 6. The equal 0 now is the only new thing. Okay, so we factored out a 5x. That was our notes for what we just did. Is this a perfect square trinomial? Perfect square, not a perfect square, so it's not. So now we need to say what multiplies to 6 and adds to -5. If you said it was -2 and -3, you are correct. So we have 5x now times the quantity of x minus 2 times the quantity of x minus 3. So now we have 3 things being multiplied together to equal 0. So we need to set them all equal to 0. Previously to this, we only had 2. Now we have 3 things. So 5x equals 0, or x minus 2 equals 0, or x minus 3 could be 0. That's the 0 product property. So dividing by 5 on both sides just gives me a 0. Adding 2 here gets me 2. Adding 3 gets me 3. So we have 3 solutions now. X could be 0, it could be 2, or it could be 3. Okay, so we are basically to this last checkpoint here. We're not going to do number 8 down here. We're just going to do this one. So pause and try number 7 and come back. All right, so you moved the 40x over by subtracting it. You factored out the 2x. That was the GCF. This is not a perfect square trinomial, so you say what multiplies to -20 and adds to 1. It's 5 and -4, so those are my factors. I set them all three equal to 0, which makes my solutions 0, -5, and 4. All right, so you're on to the practice or talking to Mrs. Wyman if you need some assistance. Great job.